Hi, welcome back.
Hi.
Hello.
Hello.
Good morning. You guys are nice and awake. You had your coffee. Yesterday, last time we were together, we talked about the general form of absolute value. And we talked about the different transformations that were possible in this format. Today, we're going to continue looking at the transformations. So we're going to have some slides left and right, slides up and down, some stretches and some compressions and some reflections. But we're going all the way back to when we did them with linear functions. And when we just had any random function. And then remember we substituted those in and we looked at how that would affect our graph. We're doing the same thing but with absolute value. All right, scooting in, I'm on the top left bucket. This is what happens when we multiply the output. Notice that we're multiplying outside. That should look really familiar from last time's this A. It's the same one. If it's bigger than bigger than 1, we have some sort of vertical stretch. And our graph is going to get skinnier. If A is between 0 and 1, we have some sort of vertical compress. So our graph is going to get fatter. Our fat is going to get graphier. That's what I was after. And if our A has a negative, we have that reflection that's happening in X. Like we did with the lines, we were able to multiply the input by some value. And we can do the same thing with the absolute value function. We can multiply the input, the stuff inside the absolute value before we take it. If our number that we're multiplying inside the function is bigger than 1, we have some sort of horizontal compression. If it's somewhere between 0 and 1, so some sort of small fraction, we've got a horizontal stretch. And if B ends up being negative, B being the number that you're multiplying inside the function, if that number is negative, we have a reflection, but this time it happens across the y-axis and not the x. Can I please have 2 questions about these 2 items? Two questions about this top portion.
Why is the second one first? For the first one, but the second one should.
Great question. So we're looking at these 2. Why is this one a squish it down vertical compression and this one a stretch? They look like they're doing the exact same thing. In essence, they are doing the exact same thing to the function, but this one is looking at in terms of what's happening to the y. And so what's happening to the y is it's getting squished down toward the x-axis, whereas this one we're looking at what's happening to the x values. And so in order to make that same vertical squash happen, you've got to grab the graph and stretch it out this way. Okay? So even though it looks like the same thing's happening, it's happening from a different mechanism. This one we're flattening, this one we're pulling. Great question, thank you. One more question about these items up here. I'm getting a lot of head shakes, so it feels like there's no more questions on this and we're feeling really good and comfortable. Okay, let's go ahead and slide on here to the adding portion. So if we're going to add to the inputs, this is going to feel really familiar from yesterday. Yesterday it looked like this. And if it was positive or negative, it told us whether it was going to go left or right. And this is the same sort of thing. If it's positive, it's moving to the left. If it's negative, it's moving to the right. So that doesn't change. These are horizontal translations. This one is to the left, and this one is to the right. We could add to the output. If we add to the output, it's going to look like that. And just like from yesterday, where it was sitting outside the absolute value, and it had some sort of shift up or down, that's what we can expect here. If it's positive, it shifts up. If it's negative, it shifts down. And these are our vertical translations. And this is up, and this is down. Can I have 2 questions about this bottom portion? Two questions about this section. Okay, again, I'm getting a lot of shakes of head, so it feels like this one is just review from yesterday, and it feels really comfortable and familiar.
Yeah.
Yes?
Yep.
Kind of? Okay, well, let's play with it and let's see if it clicks in and feels a little bit better. I have 3 different graphs. I'd love to do at least one of these with you. Which, the last one? This one here on the right? Okay, so let's start with this one here on the right. All right, as I'm looking at the graph, I see that we've got 2 functions to graph. They're giving me k of x equals the absolute value of x plus 4. And it looks like that's the graph they already drew for me. Because if I think back to what my parent function would look like, can I borrow your pencil? Because I want to draw the parent function, but I want to do it very lightly. So drawing this one in pencil, the parent function would look something like this. Trying really hard to draw straight lines. Okay? Very light. That's what the parent function would look like. And if I looked at this as some sort of slide, that would be this one from yesterday, it would shift 4 units to the left. And it shifted 4 to the left. 1, 2, 3, 4. There's the new one. So this function right here is our k of x. Okay? That's where we're starting. That's this one. We want g of x, and g of x is asking us to take k of x and put a negative inside of it, and then do this. So I'm going to look first at this inside portion. So this inside portion looks like I'm multiplying the input, so it's this box up here. And because it's negative, I have a reflection, but across the y-axis. This means that anything that showed up on the left side of the graph is now going to be on the right side of the graph. And anything that was on the right side of the graph is going to be on the left side of the graph. So I'm going to color this transformation only in pink. And this transformation is my reflect across the y-axis. Okay, I'm going to start with this little piece right here. Here's the line of reflection, the y-axis. I'm going to color that in pink so that you can see it. So there's my line of reflection. Okay, so if I look at this portion of the line, this point is 1 unit away from the line of reflection. So in the other direction, I'm going to go 1 unit out and put a dot. That one's 2 and put a dot. And so this top part of the graph gets reflected across the y-axis that way. Can I have a question from you guys about that portion before I move on? Just because it's a shorter piece of line and easier to think through. The only reason why I picked that piece to reflect first. Thank you. I'm going to go ahead and reflect the rest of this using the same method. I'm just counting how far away these points are from the line of reflection, my y-axis, and I'm putting a dot on the opposite side. Can I have a question about that before I move on?
What did it reflect over the y-axis?
It reflects over the y-axis because I have a negative in the multiplying in the input of the function. And according to my notes at the very top, if I have something being multiplied to the input of the function and that something is negative, it reflects against the y-axis. Okay, great question, thank you. The next thing I'm going to do is I'm going to handle this, which is some sort of vertical shift down. How far am I going to shift it down? 1. I'm going to take the pink graph, which was the most recent thing that I was working with, and I'm going to shift it down 1 unit. And this is why it's important to have those different colors, because as we do each step, we end up with a bunch of different graphs. And so we want to be able to know which one we're ending with. So I'm just going to take all these points that I'd already graphed, and I'm just going to push them down 1 unit all the way until I'm done with my graph. And so this green function is my final transformation, g of x. All of the information that I'm being asked for at the bottom, the vertex, the axis of symmetry, the x and the y-intercepts, those are all in relationship to the final g of x function that I drew at the very end. All right, what's the vertex of this green function?
4, -1.
There it is. Here's my vertex. You said it was 4, -1?
Yes.
Beautiful. The axis of symmetry is always that vertical line that cuts straight through the vertex. 4. Remember that this is a line, and so I want to write it as an equation. It's always a vertical line, and so the equation is always x equals, and the value is always the x-coordinate of your vertex. The x-intercept. There's 2 of them. I'm so glad that you noticed. 1 and 2. You must list both. 3, 0, and 5, 0. Notice that they're the same distance away from that axis of symmetry. My axis of symmetry had an x value of 4. The point 30 is 1 unit away from 4, and the point 50 is 1 unit away from 4. They're the same distance because the axis of symmetry is a fold line. All right, y-intercept. 0, 3. Here it is right here. And I'm going to give you like a little key on what, there it is. So that way you can refer back to your graph and see where I pulled that information. Can I have 2 questions about this piece right here?
Why didn't you graph both Y's?
Why did I graph both y's?
Didn't you? Because you got, the points, like for x, you got 2 of them. There's also 2 points for y. There's 0, 3, and then 0, 4.
0, 3, and then 0, 4. Okay, because we're looking only at the green graph. Yeah, so we're asking where does the green graph touch the y-axis?
Okay.
Fantastic question, thank you. Can I have one more question about what we just did? I'm hearing some conversation. I'm assuming you're just kind of chatting yourself through this and try to finding that one question. Why is it too easy? Because you guys are that intelligent. No, it's supposed to be this easy. It's really easy to overthink and try to make complicated. Don't make it complicated. Don't overthink it. It's this easy. All right, let's end this with a quick reminder conversation about domain and range. What was domain again?
X.
All the x value, which in this case I heard someone say was all real numbers. What would be the range of this thing? -1 to infinity. Can I have a question about that domain and range?
How would you do like the y? The y greater than 3 10.
How would you write the range as an inequality?
Yeah.
Great. So let's say you don't want to write it in this interval notation because the infinities are hard to draw and you don't want to deal with it. You could write it as the inequality y. Since my graph is opening upwards, I'm going to select the greater than because it's opening up. Because the vertex is filled in, solid points, I'm going to make it or equal to. And then I'm going to select that lowest y coordinate, which in this case is the y coordinate of your minimum. Your minimum is your vertex. And so this really is just the y coordinate of your vertex. So this is how you would write it as an inequality. Great question. Thank you. We have 2 more graphs. Do y'all want to see whole group another example with the other 2 graphs, or are we feeling good and just want me to wander around?
The middle one, but you good.
Okay, looking good. I heard one person call for the middle one. Can I get a thumbs up? How many people want to see the middle one real quick as a whole group? Okay, so I've got a few. Those of you who don't want to see the middle one, you guys are welcome to ignore me at this time and start working on the homework. But by ignoring me, please don't talk yet because I'm going to do the middle one. For those of you who want, so those of you who gave me that thumbs up, there was a couple people on this side, some people here in the middle, and then this row over here. I'd like you please make sure the phones are off to the side and that I have your full and mostly undivided attention. All right, so there's nothing graphed here. That's a problem. Where do I start? So if I look at this first one, what does this look like is happening?
Going to the left.
Change.
We're changing. What kind of function are we changing? What's the parent function? Well, if I took away all the transformations, I'd be left with just this thing. Absolute value of x. So I could think of this way. If I had my absolute value function, which I'm going to draw in black for you, it would look like this. All absolute value functions, the parent functions look like that. It starts at 0, 0, and it goes up on the diagonal to the right, and it goes up on the diagonal to the left. Okay? Then I'm going to look at this piece. And I'm going to ask myself what's happening right there. What's happening right there? Well, that looks like this, doesn't it? Yeah, it kind of does. It looks like this one, which is a vertical shift down. So that means I'm going to shift this entire graph down 3 units. So this point is going to go 1, 2, 3. This point 1, 2, 3. This point 1, 2, 3. This point 1, 2, 3. And it looks like it's just doing that. And then same thing on the other side. And this is the h of x function. Can I have a question about that? Looking at those of you who wanted to see this one. Fine, we're okay? You don't have a question on it? Okay. So now I'm gonna look at g of x and I'm gonna graph it in blue because it looks like the change that's happening is right in there. And that looks like we're adding to the input. Because it's negative, we're gonna shift it to the right. So this is a shift right 4 units. All right, so I'm gonna take the green. I'm looking at the green because that was the most recent one. And I'm gonna shove the green to the right 4 units. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Looks like it's doing this. And the function that we're being asked to find information for is the blue function g of x. Was that the only concern, was getting the graphs in? And from here you could run the rest, or do you want, those of you who are needing to see this one, are you wanting me to walk through the vertex and the axis symmetry and all the rest of that?
Yeah.
Yeah? Okay. Are you ready for me to move on with that one? Yes, Andrew? You ready for me to do vertex and stuff?
Yeah.
Okay. So vertex is going to be where the graph stops and turns around and goes the other direction. So I need the coordinates of that.
4, -3.
4, -3. Axis of symmetry is always some sort of straight line cutting through the vertex. Because it's a straight line, the equation is always x equals. And because it goes through the vertex, I'm just going to grab the x-coordinate of the vertex and write it down. X-intercept is where it crosses the x-axis. I have one here. And I have one out here somewhere, but I don't really know where that is.
7.
How do you know it's 7? Guess, because it felt right. I love that. Why are you saying it's 6?
That's 6. Is it on the 6? No.
Because here's the 6 right here, and it looks like my graph just barely misses it. Yeah. Here's how his guess of 7 worked out. This x-intercept is 1, 2, 3 units away from my axis of symmetry. My axis of symmetry is the point where it like folds over, and so all of those points are the same distance away from my axis of symmetry. So if this intercept is 3 units away, then this intercept is 3 units away. 1, 2, 3. 1, 2, 3. So this is at 7. So my intercepts are 1, 0, 7, 0. Great eye. The y-intercept is where I cross the y-axis. It looks like it's happening right there at 0, 1. Do you want a refresher on domain and range as well, or are we okay now? We're okay? We're all right? We're good? Alex, we're good, or do you need to see domain and range again?
No.
No, you're good? All right, thank you guys very much.